Hi, Phil Plait from badastronomy.com. Welcome to q&ba, where I answer your questions about astronomy. This week's vacuous question comes from Walter L. Williams, and he asks, when we talk of the vacuum of space, is it a total vacuum or pretty much a vacuum? Could you elaborate, perhaps telling us how much matter might be in, say, a liter of space? Well, first of all, astronomers don't use liters. We use cubic centimeters. They're smaller, and that means there are more of them, and I think we do that because we like really big numbers, so we get to use more. Well, a cubic centimeter is about this big. My mini marshmallow cubic centimeter model makes its return appearance. This guy right here is just about a cubic centimeter, and this is a really good volume to use because it's pretty easy to understand it, and I'm used to using them. I use them all the time, and I guess that means I'm not a born leader. Well, we're sitting here on Earth, and there are a lot of molecules per cubic centimeter here in the air we're sitting in. How many are there? Well, if you do all the math, the number you get is about 10 to the 19, 10 quintillion molecules per cubic centimeter here. That's really, really dense. That's a lot of particles per cubic centimeter, especially compared to space. If you go out into space, and you don't have to go very far, just the distance of the moon, 400,000 kilometers, something like that, you find that there are only about 10 particles per cubic centimeter. And that's hardly any. I mean, 10 quintillion here versus just 10. No quintillion, just 10 out in near space, just out at the moon. So that right there is a really hard vacuum. It's pretty amazing. But even that's a lot compared to interstellar space. If you go out between the stars, you might only have a density of about 0.1 to 1 particles per cubic centimeter, which means that at most you might find just one particle floating around in space inside of a volume like this. In general, you might have to, go out to see something like this big to find one particle. But it also depends on what you mean by space, because space isn't just empty, it's not just smooth, it's got parts of it that have more density and parts that have less. Now, if you go out into, say, a gas cloud, one of these gorgeous nebulae that you see these pictures of all the time, there are a lot more particles. You might find as many as 10,000 to 100,000 particles per cubic centimeter. And that's actually considered to be fairly dense in space. But there's another type of object, and now I'm not talking about stars and planets, of course. These are sort of well, they're not solid, but they're sort of discrete objects. I'm talking about gas clouds and something like that out in space. The densest type of these is what's called a molecular cloud, and these are very dark, dense objects, and it's what stars form from. And in the cores of these things, where they're really dense, you might get 1 million particles per cubic centimeter, 10 to the 6 particles. And now, when I was in grad school and I was taking a class in the interstellar medium and what exists out there beyond the stars, I remember learning that and thinking, wow, that's really dense. And that was sort of the astronomy guy. I was in astronomy zone thinking, wow, 1 million particles per cubic centimeter, that's incredibly dense. And then, sort of real guy Phil backed out of that and said, 1 million? That's a vacuum. That's like nothing. They're 10 to the 19 particles per cubic centimeter in the air we breathe. How can you possibly consider 1 million particles per cubic centimeter dense? It's like a vacuum. And the reason, of course, these things look so thick and look so dense is because they're huge. You're looking through them and they can be light years and light years across. And so when you're talking about that many cubic centimeters, it's a lot of particles. But still, compared to the Earth, that's a vacuum. And I think it's funny, I love to sort of mix my astronomy life with my real life, and even I'm surprised at the universe sometimes when I do. Well, that's it for this week's episode of q&ba. If you have a question, email me at thebadastronomer@gmail.com. Well, for badastronomy.com and q&ba, I'm Phil Plait.